Bismillah. Hello everyone, this is Dr. Gamal from your channel Think Math and welcome to a new video. Today we are going to talk about even and odd functions. But before we talk about even and odd functions, we need to talk about the symmetry of the graphs. So a symmetry about the y-axis is when a graph like this is split in two halves by the y-axis. We see that this function, the curve of this function, f of x equals x squared, is split in half by the y-axis, and we notice that we have the 2 points negative 2 and 4 and the point 2 and 4 lie on the same graph. So if we have a point A whose coordinates are x and y and another point A prime whose coordinates are negative x and y, these 2 points will lie on the same graph. In that case, we call that the curve is symmetric about the y-axis. Another kind of symmetry is the symmetry about the origin. Here we notice that the curve is split by the origin into two identical curves, one in the bottom left and one in the top right. So if we have 2 points A whose coordinates are x and y, and another point A prime whose coordinates are negative x and negative y, both of them lying on the same graph or on the curve of the function, then this curve is called to be symmetric about the origin. Like here we see that we have the 2 points 2 and 8 and the other point negative 2 and negative 8 both lie in the curve of the function, and this function is f of x equals x cubed. A third type of symmetry is the symmetry about the x-axis, and we notice here that we have 2 points lying on the same graph. This graph is split by the x-axis into two halves, one in the positive xy direction and one in the positive x and negative y quadrant. Here we notice that the 2 points 4 and 2 and the points 4 and negative 2, and this is a representation of the relation f of x, let's call it, not get it, f y equals square root of x. And we see that here we have 2 points x and y, this is a point A, and another point A prime whose coordinates are x and negative y, both lie on the curve, but we notice that this is not a function and this is a relation, not a function, because it does not pass the vertical line test. And if you don't remember the vertical line test, we talked about it in the difference between relations and functions, and you can check the video in the playlist that will appear in the description. So now let's talk about the even functions. So the even function is defined by that if for an even function, if f of negative x is equal to f of x, then this is called an even function. For example, here we have the curve of x squared, f of x equals x squared. So we replace every x and put negative x. So let's find what's the function, what is the y value of the f of negative x. So f of negative x equals negative x all squared, which is going to be equal to x squared again. So, and this is equal to f of x. So if we have a function that where f of negative x is equal to f of x, this is called an even function. On the other hand, what's an odd function? An odd function is defined by that f of negative x is equal to negative f of x. For example, here we have the cubic function f of x equals x cubed. So let's replace every x and put negative x. So f of negative x equals negative x all to the power of 3, which is equal to negative x cubed, or negative f of x, the original one that we have. So this is an odd function. If we replace x with a negative x and we find something different than f of x and negative f of x, then this function is called neither even nor odd. Let's have another example. If g of x equals x squared minus 2x plus 3. Let's check what's g of negative x. G of negative x equals negative x squared minus 2 times negative x plus 3, which is equal to x squared plus, for the confusion, let's change this. This is a multiplication sign, not an x. Okay, plus 2x plus 3, which is not equal to g of x. So this function is neither even nor odd function. Now let's look at some of the properties of even and odd functions. If we have two functions, f of x or f1 of x and f2 of x, and both of them are even, if we get a new function h of x, which is equal to f1 of x plus f2 of x, is this an even or an odd function? Let's find out. So let's try h of negative x is going to be equal to f1 of negative x plus f2 of negative x, which is going to be equal to f1 of x plus f2 of x, which is the original h of x, so this is an even function. Now what about subtraction? So if we have g of x equals equals f1 of x plus f2 of x, minus f2 of x. So let's get g of negative x is going to be equal to f1 of negative x minus f2 of negative x, which is equal to f1 of x minus f2 of x, which is equal to g of x. So we return back to the original function, then this is an even function. Okay. Let's look at multiplication. So if we have h of x equals f1 of x multiplied by f2 of x. So what's h of negative x? It's going to be equal to h f1 of x, f1 of negative x times f2 of negative x, which is going to be equal to f1 of x times f2 of x, which is the original h of x. So this is an even function. What about division? If we have m of x equals f1 of x divided by f2 of x, where f2 of x on the parts where f2 of x is not equal to 0. So this, let's take m of negative x, it's going to be equal to f1 of negative x divided by f2 of negative x, which is going to be equal to f1 of x divided by f2 of x, which is equal to m of x. So this is an even function. Now what about the relations between odd functions. If we have two functions, g1 of x and g2 of x, and both of them are odd, let's check their relations. Okay, so if we have h of x equals g1 of x plus g2 of x, what's h of negative x? It's going to be equal to g1 of negative x plus g2 of negative x. And remember that this is an odd function, so g1 and g2 are both odd functions, so this is going to be equal to negative g1 of x plus negative g2 of x, which is equal to negative g1 of x minus g2 of x, which is equal to negative of g1 of x plus g2 of x. And we notice that this is our original h of x, so this is negative h of x. So we got the negative of the original function, so this is an odd function. So the sum of two odd functions is an odd function. Okay, now what about the difference? If we have another function h of x equals g1 of x minus g2 of x, so what's h of negative x? It's going to be equal to g of negative x minus g1 of negative x minus g2 of negative x, which is going to be equal to negative g of x, g1 of x, plus g2 of x, which is equal to negative of g1 of x plus minus g2 of x, which is negative of the original function. So what we got here now is the negative of this one, so this is an odd function. Now what about multiplication? So if we have m of x equals g1 of x multiplied by g2 of x, so it's going to be equal to let's find m of negative x. It's going to be equal to g1 of negative x multiplied by g2 of negative x, or it's going to be equal negative g of x, g1 of x, times negative g2 of x. So it's going to be, the negatives will cancel out, so it's going to be equal to g1 of x multiplied by g2 of x, which returns us to the original function m of x, which is equal to m of x. So this is an even function. Okay, what about division? If we have n of x is equal to g1 of x divided by g2 of x, provided that g2 of x is not equal to 0. So what's n of negative x equals g1 of negative x divided by g2 of negative x, which is equal to negative g1 of x divided by negative g2 of x, and the negatives will cancel out, so we get the original g1 of x divided by g2 of x, which is the original function n of x. So this is an even function. Now what about the combination of even and odd functions? If we have g of x, an odd function, and h of x, of f of x, even. If we have h of x equal to g of x plus f of x. So h of negative x, to test if it is even or odd, we test h of x is equal to g of negative x plus f of negative x. So this is going to be equal to negative g of x plus f of x. Okay, so what is the relation between h of x and h of negative x? So h of x is not equal to h of negative x, and h of x is not equal to negative h of x. So it's neither even nor odd. Okay. What about subtraction? So if h of x is equal to g of x minus f of x, so h of negative x equals g of negative x minus f of negative x, which is equal to negative g of x minus f of x, which is equal to negative g of x plus f of x, which is now h of x is not equal to h of negative x, and it's not equal to negative h of x. So again, this is also neither even nor odd. Okay, now let's check multiplication. So if we have m of x equals g of x multiplied by f of x, Okay, what would m of negative x be? It's going to be equal to g of negative x multiplied by f of negative x, which is going to be equal to negative g of x multiplied by f of x, which is going to be equal to negative of the original function of m of x. So the multiplication of an even and odd function is an odd function. Okay. Now let's check division. If n of x equals g of x divided by f of x, where f of x is not equal to 0. Okay. Okay, so n of negative x is going to be equal to g of negative x divided by f of negative x, which is equal to negative g of x divided by f of x, which is the negative of the original function, negative n of x. So this is an odd. So the division of an odd function over an even function is an odd function. And it's easy to show that the division of an even function over an odd function, which means that if we put the even function in the numerator and the odd function in the denominator, we will get the same result, and odd function as well. Okay, now let's summarize this. So the relations between even and odd functions, if we combine them in some operations, so even functions plus or minus even functions gives us even functions. Even functions multiplied or divided by even functions give us even functions. Odd functions added or subtracted from odd functions gives us odd functions. When we multiply or divide odd functions together, we get an even function. Notice this very carefully. And even functions plus or minus odd functions is neither even nor odd functions. And odd functions multiplied or divided by even functions gives us even functions. Let's take another example. If f of x equals 1 over x. So what is the reciprocal function? Is it an odd or an even function? So let's get f of negative x equals 1 over negative x, which is clearly negative 1 over x, which is the equals negative the original function f of x. So it is an odd function. Now let's look at this interesting example. If f of x is a quadratic function equals ax squared plus bx plus c, and a is not equal to 0, and we are told that this is an even function, Okay, so show that b equals 0. Okay, so to solve this question, we are told that um, this function is an even function, which means that f of x equals f of negative x, or f of negative x, which is going to be equal to a times negative x all squared plus b times negative x plus c is going to be equal to ax squared minus bx plus c, and since it's an even function, this is going to be equal to f of x, the original one, which is ax squared plus bx plus c, and this can be only true if and only if negative b equals b, because we are going to equate the coefficients of the like terms in both the left side hand side and the right hand side. So a equals a and b equals negative b and c equals c, and this means that negative b equals b, and this can be only true if and only if b equals 0. Okay, and now we have proved this. Okay, that's it for today's video. I hope that you have learned something new, and the explanation was clear and good. Uh, Please like and subscribe for more math related videos, and check the description for the playlist of the previous lessons. And if you need a personalized help in math, check the links in the description. And hope to see you in next videos, and bye.